Great. Good afternoon, everybody. My name's James Cadman. I work for Action Sustainability, the business behind the Supply Chain Sustainability School. And we are having a 1 hour lunch and learn today on climate change adaptation on site. And we've got some guest speakers from Keepmoat Homes who are going to give their perspective to adaptation, possibly the poor cousin of the climate change action that we're all trying to take to address the things that we see out of our window today. I was just saying to Ben and Andrew that it couldn't be a more appropriate day to be talking about climate change adaptation with what's going on across most of the UK with our latest heat wave. So thank you for joining. We've got an hour of blended learning and case studies and different kinds of material in and around climate change adaptation, and we're going to have a few questions with you as well afterwards. So just bring up the agenda. So I'm going to give you a brief scene setting, what climate change adaptation is all about, where it's coming from, what the reality is and the reason behind it. We're then going to move into a Menti poll. I've got 5 questions for you. And for any of you who've been on a supply chain school webinar or lunch and learn recently, you will have done a Menti question quiz at some point. So get your phones ready for that. And then I'll hand over to Ben, Head of Sustainability at Keepmoat, who's going to take you through their experience around adaptation on site, some of their construction sites. We'll then close with a bit of Q&A. So if you do have any questions for myself or for Ben or Andrew, please put them in the Q&A box that's on your screen, not the chat box, the Q&A one, the one with the 2 speech bubbles and Q&A written underneath, and then we can pick those up. And then we'll close by 1 o'clock. Just some brief house rules. Do get involved in the Menti questions. It really helps grow the knowledge and grow the understanding of where the sector is at. As I say, use the Q&A for any questions that you might have. We do have the upvoting function within Zoom. So if you see someone else's question and you think they've asked exactly what I want to ask, great, just give it a like, give it a thumbs up, and that will push it up the list of questions. There's no need to type the question in again. My colleague Toby will be sharing a feedback link near the end of the webinar. It's always good for us to get your feedback, find out what you like, what you think we should be doing in addition, what we could be doing better, that kind of continuous learning. So please do fill that in. And we will be sharing the slides and the recording afterwards as well, if you want to watch it again, or you have any colleagues you'd like to share it with as well. So if you do want to take notes, by all means do so, but don't frantically scribble any down, because you will get the slides as well. Okay, and just a brief heads up on what Mentimeter is for the few of you who may still have yet to enjoy the delights of Mentimeter. It's a very simple polling piece of software. You can use your smartphone or your laptop, whichever device you're working off. There is an app for it, but you don't need to download the app necessarily. You just go to www.menti.com and you get a screen which looks like the one on the left. At the right time, I'll give you a PIN code. I won't give it you just yet, so hold your horses on that one. You'll get an 8-digit PIN, you pop that in, and then we're up and running. If you're using your laptop, it's better on Google Chrome as your browser rather than Microsoft Edge for some reason. I'm no IT expert. So if you can do that, then do. And then importantly, don't disconnect from this Zoom. They can work in parallel side by side. Okay. So some brief context about climate change and adaptation in particular, just to set the scene. I've got a couple of graphs which set the scene for where we've been and why adaptation is really important. What you're looking at on the screen at the moment is a graph of the average temperature of the Earth going back 20-odd thousand years. And it starts at 0, meaning there's no change from modern day, basically. So if you look on the left-hand side of the graph, you can see it dip down. It was a lot colder than it is by modern day standards. And that was basically the last ice age. It was 6 or 7 degrees cooler over the whole Earth about 20,000 years ago. And then it started warming up. The last ice age finished, essentially. And then we got to this flat piece here that's called the Holocene. And that's essentially where the Earth's temperature has stayed stable for a good 10,000 years. That allowed us as humans to settle down, to start agriculture, to form towns and cities eventually, and ultimately lead to where we are today. So we've had this really stable climate that we've been able to enjoy, and that we've adapted to. The planet has adapted to it. We've adapted to that stability in the weather and stability in the temperature. There are a few bumps along the way, of course, but essentially it's been the same for a good 10,000 years. But you can see on the right-hand side, the Earth's temperature is starting to tick up. It's rising. It's getting warmer than it has been over those last 10,000 years or so of the Holocene. And this is where adaptation comes in. How quickly can we, as humans, but also the rest of the planet, adapt to what's happening because of climate change? Bringing that a bit closer in to the last 200 years or so since the Industrial Revolution, the Earth's temperature has gone up by about 1.1 degrees on average globally since that time. And you can see that blue line is fitting the trend going up. The red is the actual measurements of temperature, and then the blue is the line that fits that. So the temperature of the Earth has gone up by just over a degree. And you might say 1 degree Celsius, what difference does that make? But it's essentially a huge amount of extra energy that's being trapped in by the greenhouse gas effect into the Earth's atmosphere. And that changes the weather patterns, it changes our climate. That's where the whole climate change hypothesis comes from. And that's been driven largely by carbon dioxide emissions. Burning of fossil fuels is the primary culprit for this. There are many others, methane emissions, nitrous oxide, others, but the primary culprit is CO2 from the combustion of fossil fuels. And what you're looking at here is the emissions of CO2 globally since 1750, so well before the Industrial Revolution. And on the horizontal, you've got the timeline out to modern day, and on the vertical, you've got the emissions in billions of tons of CO2. And you can see that from about 1850, it started to move up, slowly move up. And then after the Second World War, it went even steeper, and it's getting steeper still. So our emissions of CO2 have gone up dramatically. And all these things tie in. CO2 emissions go up, the average global temperature has gone up, and you'll see the consequences of that. What that means globally is that the temperature has gone up, but at different rates in different places. It's not equal all the way around the globe. As I've been stressing, that global temperature rise of 1.1 degrees Celsius is an average. It's more extreme at the polar parts of the globe, the North and South Pole. Temperature rises there of 4, 5, 6 degrees higher than they were before the Industrial Revolution. So it's an unequal distribution of the impacts. And that comes back to adaptation as well. We in Western Europe have not really had to adapt that much because our temperature rise hasn't been that extreme compared to the rest of the world. But other parts of the world have really had to adapt, where you have permafrost melting, for example, and you have ice caps melting and so on. So the rate of adaptation is unequal. It's distributed unevenly across the globe. I don't need to show you these pictures. We see them on the news regularly these days, the extreme weather patterns that happen as a consequence of climate change. So just to be clear, weather is what happens on a daily basis. Climate change is a longer term trend over 30 or more years. But what essentially is happening is we pump up more CO2 into the atmosphere. We're trapping it in the atmosphere. That's the greenhouse gas effect. That traps in the energy as well. That extra degree Celsius of temperature is a huge amount of extra energy. That energy has to go somewhere. So either as heat and it melts the polar caps, or it has an effect of more frequent and more extreme flooding, storms, wildfires, the extreme temperature we're experiencing across many parts of the world at the moment. Spain, Portugal are experiencing 46, 47 degrees at present. So you can see there's many different impacts. And the key thing is that we need to not only reduce our emissions, that's mitigation, but we need to adapt as well. It's here, it's now, it's happening. We need to adapt what we do, the infrastructure we build, the housing we build, and how we live and run our lives. All needs to be adapted to the greater frequency and greater extremity of these weather events. And this is a lovely picture from the Met Office that shows the change in global average temperatures going back to 1850. So it's similar to the graphs that I've shown before, but it just really brings it home how different the Earth's temperature is compared to 1850 on an ongoing cycle. I'm sure you've heard certain statistics such as the 10 warmest years on record have been within the last 12 years. And you can see on that right-hand end where those warmest years are all piling up. And again, it's showing that the change in temperature difference is over 1 degree Celsius now. So some of these pictures, very simple pictures, but they bring home the message that the temperature is going up and we need to adapt. So adaptation itself. The UK from DEFRA has the Climate Change Act and the National Adaptation Programme, and it focuses on some really key areas of how we need to adapt to a changing climate, changing weather patterns. Flooding impacts, both coastal and inland, in terms of the impacts that we can see on the infrastructure and the assets we have. High temperatures, clearly that's a big impact. It's been all over the news the last few days. The risk to health, the risk to productivity, the risk to transport, that's come on the news as well a lot as well. If there's ongoing prolonged heat waves, we're looking at public water supply risks as reservoirs get depleted and lack of rainfall. And then the risk to natural capital. You're looking at flora and fauna and the risks to them through excessive heat and lack of water. Loads of wildfires happening at the moment in southern Europe. Many of them huge, consuming huge areas of land all across Spain, the Iberian Peninsula, southern France and Italy as well. So all of these risks come together. Just bring that up. And I mentioned mitigation earlier. These are two sides of the same coin, mitigation and adaptation. Mitigation is essentially consume less, use less energy, emit less carbon, less GHG emissions. Adaptation is saying, we know that there's change happening now. It has been for several years. We need to adapt the way of work, the way we live, the way we travel, the way we manufacture our products and services, and adapt to a different way of working. And you can see some of the examples on the screen as to what we can do about that. Some of them overlap. Clearly, they're not mutually exclusive. There is some overlap, but there's lots and lots of things we can do, which is promising. That there isn't just one silver bullet that everybody's going to be clamoring for as a technology. We can do different things depending on our situation, on our budget, on our geographic location, and so on. One example that has an element of adaptation to it in the housing sector, some eco homes that were built in Leeds. I'll just get all the bullet points up first and then I'll talk to them. They looked at all different ways of designing and building housing. This happened to be in Leeds. So you're looking at mitigation and adaptation here, about making sure that they are manufactured as close to the site as possible to reduce transport. The elements, the fabric of the building themselves is done in a way that minimizes the energy consumption. It's the mitigation piece, as well as PV panels and so on. But also the way that the buildings are designed is to adapt to a changing environment as well. The fabric and how they're located and how they're powered as well. There's a link on the screen as well, so you can go and find that should you be more interested in looking at that in the future. So how might things change? Those four key aspects that I mentioned earlier, from DEFRA, flooding, drought, storms and heat waves. These are the main things that are challenging our planet and challenging the UK, even though, as I say, we are probably more shielded from it at the moment than some of the other parts of the world. It's definitely happening. So just very quickly, the impact of flooding shouldn't really need stating, but it's our critical infrastructure, whether that's power and electric, whether that's transport, whether it's production of food, it's people's homes as well, of course. Flooding can be devastating and take a long time to recover from, and the huge costs that go with that as well. So thinking about how we can deal with the risk of flooding in the design and operation of our assets is really crucial. So working more in tune with nature in terms of what we can do to adapt, putting in sustainable urban drainage systems, so we attenuate, take the water away as much as possible, holding ponds, other different methods. And these can have other benefits as well. If we look at the landscape and use the landscape to help manage flooding risks, that can bring biodiversity benefits as well. So it's working in tune with not just the risk of the flood, but it's the wider catchment area. It's working with the farming community if it's in a rural environment. So it's thinking more widely, more holistically in terms of what we can actually achieve. Drought, the opposite end of the scale. How can we make sure that we look after our water resources, make sure that we maximize the opportunity for gathering water and keeping water? And clearly the risks from drought are to our agricultural crops, to those parts of industry that require huge amounts of water, either for production or for cooling. Water's kind of taken for granted in the UK because it generally rains a lot, supposedly, and water is cheap. Water is very cheap, so it's taken for granted. But when you get situations like this, we do really need to consider it, particularly if we want to maintain security of supply and resilience of our assets, not only just drinking water, but as I say, all the other production that is undertaken in the manufacturing sector. So yes, it's obviously using less water, being efficient with our water. What appliances do we have to conserve water? Can we capture rainwater when it happens and use that? Can we recycle grey water? So that's water that comes from the backs of dishwashers and washing machines. That kind of water. Can that be treated so it can then be used for irrigation purposes, for example? Making sure that we manage as much of it as possible and deal with the risk of when a drought might happen so that we have enough storage to go with it. Storms. We obviously get some storms in the UK. They get very colourful names whenever they come through, but they can have huge amount of damage to property and to lives. And again, that takes a long time to repair, a lot of money to repair. And they can, again, knock out critical infrastructure in the way that flooding can knock out power stations and transport links. Storms can do the same, albeit in a different way. So whether that's energy or water or our major roads, storms can have a devastating effect across what we do. As I say, we're relatively shielded in the UK. They are far more extreme in the Caribbean and other parts of the world, off the southeast coast of Africa and in southern Asia as well. But we do nonetheless get affected. So we need to adapt what we build and what we run to deal with the higher risk, the more frequent risk of storms. So again, it's making our assets more resistant, more resilient to those storms, moving them away from those areas of risk. Can they deal with stronger forces of winds and making them more robust for the future as well? So a big key part of adaptation is thinking about what those assets need to do now, but also in 20, 30, 40 years time as well. So we're designing through their lifetime, not just for the immediate future as well. And lastly, heat waves couldn't be more appropriate today. Clearly, there's a big impact on buckling railway lines we've heard about from National Rail already today and yesterday. Clearly, there's a risk to people's lives through heat stroke and stress. But also the provision of energy, it ties in with the water as well. If we need cooling in a heat wave and there's not enough water, these things have a positive feedback loop, positive being a bad thing in this case, that it just gets worse and worse and worse. So we need to look across all of these issues and work them in tandem. So yeah, reducing that heat load where possible. So if you can reduce the cooling needed, so you can use less water and you're less risk of heat stress, then that's clearly a way to go. Looking at ways to reduce pressure and impacts on health and emergency services. How can we help people to stay cool at these hotter times? And then designing in our assets as well. How can we design new assets and retrofit existing assets to be able to withstand greater temperature extremes, whether that's the material themselves or how they're operated. You go to many parts of the world and they have roads that are designed, the asphalt in those roads is designed specifically to withstand higher temperatures. We generally don't need that or haven't generally needed that in the UK, but as time goes on, we might need to move to some of those mixes. Chocolate bars in Australia, for example, can withstand higher temperature extremes than they can in the UK. So they have a different recipe for their chocolate bars. They've adapted their chocolate to the Australian environment. It's the same way of thinking, it's just doing it for our critical infrastructure and our critical assets. Okay, that's me done on the overview of adaptation and how we need to blend it in with everything that we do alongside mitigation. If we jump onto Mentimeter, I've got 5 questions for you before I hand over to Ben. So just to repeat, you go to menti.com. It's easiest on your phone if you have one. If you don't have a phone, open another tab browser on your laptop and you'll get a screen up that looks similar to this. I'll just flip screens and then you can see the PIN code that you need to put in. And here it is at the top of the screen, 3834 8253. So that's 3834 8253. You shouldn't need to put anything else in other than that PIN code. You hit enter. It's all anonymous from here on in, so you don't have to worry about giving a right or wrong answer. And then as you can see on the screen, does your organization's climate change strategy explicitly include adaptation? And you've got four options on your screen. Yes, in development, no, don't know. So I'll just give you a few seconds to do that. Okay, so we've got 18 of you responded. Thank you very much. We're getting roughly 50% of you aren't sure, which is fine. Go off and find out, go and have a look at your website, go and speak to your sustainability folks. We're seeing this developing more and more, where organizations, it's a kind of a maturity thing. You look inside your organization first of all, and rightly so, get your own house in order. Can we reduce our energy use? Can we reduce our diesel use, for example? And then as organizations mature with their strategy on climate change, they think, that's the mitigation piece largely. What can we do to adapt our service and our product as well? So adapt our business to a changing environment, but also adapt our products and our goods and services where relevant to that change as well. Okay, cool. Thank you, everybody. We'll push on to question 2. So what adaptation measures do you deploy? So what you should get here is an opportunity to put in a few words or short sentence, and it will come up with a word cloud when you press enter. What kind of things are you doing in your organization to adapt? And as I say, either at an organizational level as a business for resilience or at a product or service level. So we're getting some coming through on vehicles. Modern methods of construction, MMC, for those of you not sure what MMC means. PV panels, different materials and recycled materials, yep. Insulation, yep. A little trick I was taught recently, in the winter, you might put hot water in a water bottle because you're cold. You can do the opposite in summer. You can put cold water in a hot water bottle and use that to keep you cool, because it maintains the coolness of that water for a long time. It's a little thing I learned recently, which was great. Shading, yeah, more shading. Shading's a really good way of adapting, because not only does it cool the air down underneath it, but it starts to set up a bit of a breeze as well, because you've got cool air and warm air, and they set up a bit of a breeze. And it provides biodiversity opportunities as well if you've got, you know, a few trees in a small copse, for example. Life cycle assessment I can see in there as well as a tool for understanding that. Hot weather working, yeah, having policies, adaptive policies in your business to adapt to a different way of working. Yeah, and triple glazing, that's another good one as well. Really make your buildings well insulated, both for heat and cool, of course, both times a year. Great, thank you. I'm going to push on. Question 3. When in the project cycle should adaptation be considered? And I've got a very condensed set of steps for the project cycle. At the brief stage, at the design stage, construction or use. And again, there's no right or wrong answer here, so don't worry about that. This is something that maybe Ben could comment on a bit later, where you think it might occur, or where it's best, I should say. I'm keen to avoid saying there's a right or wrong answer, because I don't think there is one. Okay, so most people are saying in the brief, so right at the beginning, think about it at the beginning, early contractor involvement, getting it in at the beginning, definitely. But then also a decent amount going through the stages as well. So continuing to think about it as projects change and as designs change a little bit. Great, thank you. Next question. What percentage of your ITTs or RFPs ask about adaptation? And this is meant in both directions. So either from your clients that come to you, an ITT that comes to you to tender, or one that you might write for your suppliers. So either way, whichever's most relevant to you. And you can see it's from none to all of them, and will be somewhere in between, of course. And what you're seeing on screen as you put in your response is the big number in blue and white is the average. And then you'll see some little spikes, which will be the discrete responses that people have put in. So someone's put in 0 and someone's put in about 90%, which is great. So you can just see the breadth here of adaptation in terms of the tendering process. So it's definitely something for development and change. Cool, I think that's plateaued off. We'll push on to the final question, I think. What do you see as the biggest risks and opportunities in developing and delivering adaptation measures. So again, you get a word cloud option here. Cost, extra cost. I love doing these. I do these all the time for the school. And when I ask this kind of question, the word cost comes out front and center. It's good to have that confirmed. Oh, I forgot to mention, by the way, if you write the same word exactly the same as somebody else, the font gets bigger. So what have we got here? Bias, yeah, that's an interesting concept. Client ownership, client budget, who has the control of the purse strings, who directs it. Bad publicity, that's an interesting one to explore. Maybe another one for Ben to pick up on in terms of the perception piece. Customer acceptance, will they pay for those adaptation measures? Do they see it as worthwhile? Changing behaviors. Knowledge and time, cost and knowledge. Yep, 3 of the key pillars of delivering a successful project. Do we know what we're doing? Have we got the money for it? And have we got the time to do it? Yeah, definitely. Cool. No, that's really useful. Thank you very much. Okay. I think we're done. Thank you for that. That final question will remain there. Should you wish to add anything else to it, that's really helpful. So great, we've got your responses to that. I'm now going to hand over to Ben Stone, Head of Sustainability at Keepmoat Homes, who's going to take us through their experience. And then when we've done with that, we'll have a bit of a Q&A. So just to remind you, do put your questions in the Q&A box if you've got any or comments that you want us to talk through just while Ben is giving his presentation. So I shall stop sharing and hand over to Ben. Thank you.
Thanks, James. Okay, let's see if I can get this to work. That one.
Mm-hmm.
Yep. Okay. Great.
So that's there.
Sharing.
Good.
Brilliant. Okay. So hi everybody. As James said, I'm Ben from Keepmoat. I thought James's introduction and slides were brilliant. Really gave a sense of scale and change across the world. I kind of wanted to talk about it slightly differently and talk about the impacts on our business and the stuff that we like to see over the short term. So sort of the climate adaptation that we need to take during construction. So hopefully this will give a bit of a feel for the change that we're seeing already and what's going to happen over the next few years. But before I do that, I was going to say I'm not quite as prepared as I want to be, and that's because the picture you can see on the screen is of a baby female sparrowhawk, which I found at the bottom of a tree in my garden this morning. So I've spent about 3 days this morning trying to get that rehomed with the local raptor group. It apparently the nest had been predated on by a larger bird of prey, so something like a buzzard, and knocked it out, and that was the one surviving chick. So I thought it was interesting though, and it's a point that I wasn't going to talk about, but I will. We're seeing bird nesting season extended early and late in the year. So traditionally you'd talk about it from March to August. As our climate warms, we're seeing that birds, particularly pigeons and common birds, can nest from February all the way up to November. And that kind of means that, you know, they're all protected when they're nesting. So we have birds nest in plots every year. And when they nest in a plot, we close that plot and it delays the works on it. So it's delayed on a number of plots every year. And as we extend this nesting season, there's the potential for those delays to expand. So, you know, we're starting to see these climate impacts coming through already. So like I said, I'll talk more about what's happening right now. And I wrote these slides before the extreme heat was coming through today, but over the last week or so, we've seen that Yorkshire Water have talked about reservoir levels being at the same level they were in 1995. And at that point, we were at the customers of Yorkshire Water had around 10 days of water left. And there was water being tankered into the region on the roads. And really what it's showing is that we're seeing these climate changes, not just the extremes that James talked about, but the sort of longer term, more gradual changes. So summers, we're seeing it getting hotter and drier, and that's becoming more difficult to manage around dust on site. Winters, we're seeing it becoming warmer and wetter. So we're getting a lot of silt and mud over a construction site. And it's this gradual change that even our site teams are starting to see and understand as well now. So when I go to site, the construction teams, the site managers, the contracts managers there, they all talk about this change that they've seen over the last 10 years and how it's becoming more extreme and more difficult to manage. So we shouldn't just think about climate change as something that's going to happen in 2100 or something that's in the distance. It's something that can have an impact on your business now, and that's kind of what I'd like to talk about. We have been looking at our own business And I should say, for a start, these pictures that you can see screen throughout the presentation are not Keepmoat sites, because there's some examples of poor practice I found on the internet. But we've been looking at our operations and what's been changing recently and what's likely to change up to sort of 2050. And we really know that the two big impacts right now that put our business at risk, put our program at risk, put us at risk of prosecution, are from dust in hotter, dry summers and mud and silt in warmer, wetter winters. So just a few stats to kind of that we've based that on. So the 7 warmest years since an 1850 to 1900 baseline have been the last 7 years up to 2021. And when we looked at the UK climate projections from 2018 and their most optimistic climate change pathway, RCP 2.6, which is about 1.5 degrees of warming up to 2100. And James has already just said, we've already got 1 degree of warming. So it's probably going to go beyond that, but this is the most optimistic baseline. We can see that we're likely to get 189% more record-breaking hot months by 2050. So over the next 30 years, we're almost going to see these extreme hot periods like we've got now doubling. And in the winter, we will also see a similar sort of thing. So we've seen between 2010 and 2020, we've seen 5% more rain and more wetter months compared to 1961 to 1990, that previous 30 years. And up to 2050 again, we're probably going to see 30% more record-breaking months of rainfall. So those are key risks for our business in that we operate on sites that have a lot of unmade ground on them. So when it's hot and dry, we have dust blowing across, and if there's sensitive receptors like schools or hospitals or cafes or paint shops for vehicles around that site, they're not going to appreciate having dust blowing all over them, or it could cause harm to them. And mud and silt, obviously running over can stop works happening, can cause hazards for people on site, can also pollute watercourses significantly. So we see these as real challenges. And when we turn that into monetary costs, the potential risks, so if we do nothing, and we just rely on our business as usual controls, you know, our end of pipe solutions where we sweep more on the roads, we have dust suppression going on, we try and put on more settlement tanks for silt, then we're looking at about £1.5 million every year of additional cost. And that can be broken down by about 15% more dust suppression, so 15% more bowsers and more damping down on site, 25% more road sweeping and having to dispose of that material off site, so £650,000 annually. And then in the winters, 25% more cleaning of gully bags to stop silt going into the surface water drains, 25% more road sweeping, and 25% more settlement pond desilting. So if we're going to have a pond on site where we allow the surface water to run into and allow the silt to settle out, we'll need to clean that out on a regular basis because it'll fill up, and we will then need to reprofile it before we hand it over as a subs pond for the finished development. But we've really been working quite strategically with this. So what I'd suggest to say is, don't just look at it as business as usual and extra cost. Think about it differently. So we think that with about £50,000 worth of additional spend a year, we can mitigate and avoid all of that above cost. So we have more environmental consulting support, more permitting support, more upfront assessment of these risks to understand how we can manage them better on site. And we try to move away from things like stripping the entire site and remediating it all in one go at the start of the job. And that's cheaper, and it has been cheaper in the past because you only bring that heavy kit to site once. But as we move into our changing climate, we'll see that phasing that operation is much more effective because it removes a lot of the unmade ground on site and it stops the dust and stops the mud and silt. And we have a much greater focus coming through in our capital expenditure processes now on environmental risks. So these climate change risks are getting costed and put into our capital expenditure process so we can budget for them right at the start and make sure the jobs are still going to stack up even with these additional costs. The other point that I wanted to make and why I put this red text on here was it's about 1.6 million of additional costs, it says there. But the other thing we found over the last few years is there's a real difficulty in getting hold of equipment. So if you don't plan up front and understand how you're going to mitigate these risks from silt or dust, you can't get the kit when you need it. So we, over the last winter, couldn't get siltbuster settlement tanks. There was a 12-week lead time on getting any of them to be able to deal with silt pollution on site. So we had to think about digging out settlement ponds and taking a different approach. In previous hot, dry summers, 18, 19, we've not been able to get damping down equipment, not been able to get bowsers because they've all been out on hire for weeks on end. And we've taken a really much more proactive approach at the start of this season to say, we know it's going to be hot and dry, so we're going to hire that kit in. And in the case of silt buster tanks, we've started buying them so that if we're going to be on site and we're going to need them for more than a year, we know it's going to be cheaper. We'll buy them up front, have them for the job, and then we can move them to another job when we need to. So it's being much more strategic about these risks, understanding them, then putting a plan in place is what I'm trying to say. I wanted to show this diagram because and try and give a feel of the scope of the risk. Now, a lot of construction site managers talk to me and they say, well, why is it just us that gets all the hassle? Surely agriculture produce more silt than us, and really they don't. So just to sort of answer that question, if anybody's got it, you know, this is the erosion rates for land-based activities. So the amount of erosion you'd get in different land types. So whether it's forested land, you get 1 ton per acre per year. For a construction site, you get 80 to 100 tons per acre per year. So regulators and local communities and local interest groups are always going to come and look at us first in terms of that pollution risk. And where it gets really risky for us is looking at the soil type on site as well. So as our climate changes, if you're working on a site with clay soils, they are really fine. So they're down at 2 microns. And that's the sort of size that if it's dust blowing off a site, it comes into this PM 2.5. So it's the particle size is a 20th of a human hair thickness. And that's the stuff that will bypass all of the filtration in your nose and your throat as you breathe it in. So if you've got kids that have got asthma, or elderly people around your development and you're blowing dust across them, it's going to have a really detrimental impact on them and it could easily stop your works. And over the winter, clay particles in water will stay in suspension for days at a time. So they won't settle out because they're so small. If you then discharge that into a watercourse, it will cloud all the water for miles downstream. It's very easy for a local community or a regulator to follow that back up to your outfall point and be able to see exactly who's polluting the watercourse. So there's some real risk factors that need to be assessed at the start to make sure we don't cause harm as our climate changes more and more. And the other big risk for these two are prosecution risks. So the news story you can see on the screen here, this was a prosecution from 2013 where a green energy scheme caused massive silt pollution into a watercourse and killed a load of mussels because it blocks out the oxygen so they couldn't breathe. So highly endangered species. The fine for that case was £4,000. So next to nothing. Historically, it was cheaper to pollute and pay the fine than it was to deal with it proactively and manage it on site. But that's changing. So over the last 6 months, the house building sector alone has seen 2 enormous silt fines. So the first on the left was in Yorkshire, and that was a £200,000 fine for silt pollution to a watercourse. The one on the right was £430,000 fine, and that was a series of £50,000 fines for different pollution incidents over the course of a year. So we're really starting to see this come through. Our regulators talk to us and tell us they know that we're a big risk in terms of pollution. They don't see that climate change is a mitigating factor because we should be considering it and planning for it at the start of the job and making sure that we have controls in place to deal with it. The only time they've told us that we would have any sort of mitigation to be able to say that we couldn't have helped it is that if it was sort of act of God. So it was something that was completely unforeseeable, an extreme weather event that meant that, you know, we did our best, but there was nothing else we could do. Every other time, regardless of the water quality in the river or regardless of the receptor that's receiving it, if we are polluting, we're at risk of prosecution. Okay, so I now have a question for you all. I think this one's going to come up in Zoom rather than in Menti. And we're going to ask a little question about pollution limits. So the 4 bottles you can see on the screen there have been made up for us by one of our laboratories, and they contain different milligrams of silt in water. So the one on the left, 40 milligrams per litre, the one on the right, 1,000 milligrams per litre. And I was going to ask, what do people think is the legal limit or the likely legal limit in an environmental permit for discharge to a watercourse? Cool, let's just give it a little bit longer. So, okay, we seem to have stopped. So that's really good to know. So it is 40 milligrams per litre. The discharge rate will never change, really, in all honesty. So the only time you will have a different limit compared to that 40 milligrams per litre is if you're discharging into an estuary and it's about to go directly out to sea. Regardless of the condition of the water you're discharging into, whether it's full of silt or full of pollutant or, you know, terrible, or if it's a ditch or it's a main river, you will almost always, from a local flood authority or the Environment Agency or SEPA or Natural Resources Wales, have a 40 or 60 milligrams per litre limit on your discharge. And that's because they're trying not to put any more load onto that watercourse. So they don't want you to chuck more silt on there, even if there's already a lot there. And a good way to test is if you take a litre bottle and you put it under the outfall from your site and you put your hand behind it. If you can't see the lines on your hand through the water, you're probably breaching a discharge consent. So really important, becoming much, much tougher to meet that level in the winter. So we're seeing much more equipment going onto sites, much more use of silt busters and settlement tanks, occasional use of chemical treatment to be able to reduce that level, because we are finding that as we get this higher load of water coming off our sites and we have a load of unmade ground, it is causing us problems and making it very difficult. Okay, let's keep going. I just wanted to finish by saying, this strategic approach is what we're really pushing within our business so that we minimize those costs and control the risk appropriately. And we've based our dust management plan on the Institute of Air Quality Management guidance. So this, just to give you like a really brief overview, it looks at 4 key activities, which I will zoom in on. Demolition, earthworks, construction and track out. It looks at the scale of the activities that are going on site and how risky they are. You then look around your site and say, well, how many sensitive receptors have you got around the development and what are the key risks there? When you've done that, you can map it and you can see around the development what you actually have in terms of key risks. So these are directly out of some of our dust management plans on sites that our technical teams write. And if the prevailing wind on the left-hand one is coming from west to east, then it's going to blow across a school and a children's centre. So at lunch times, at break times, at start of day, at end of day, we need to really manage our activities to make sure we're not blowing dust across those sites and causing harm to them. And the one on the right is included just to show the main haul route to and from site. So we obviously have to sweep on these, make sure that we're controlling vehicles that are coming and going, that they are sheeted and not causing dust emissions across the site. And like I say, right now, we're having some really tough conditions on really dry sites where there is dust blowing across, and we can barely keep up with the damping down at the moment to stay compliant. So we ensure that as we go through that process, we look at the key risks, and then in the IAQM guidance, there's a number of common controls for each of those activities you can put in place, and you can just make sure, depending on the risk, you implement those on site. The other plan is around surface water. And again, we take so again, of our plans, we have these key risk features at the start of the plan, which allow our internal teams to assess what the potential risk from surface water pollution is, whether it's got a watercourse near the site boundary, is there a SSSI or a national park downstream from the site, are we expected to have a lot of rain, or is it steep and exposed? And depending on the risk rating, the RAG rating that we get, we then decide whether we can go ahead with our standard controls, whether we just crack on and work with what we would always put on site, if we need a plan that's developed internally, a medium risk, or we go out to an external consultant. And we're leaning more and more on external consultants to deliver this, and then to provide environmental clerk of works positions on site as well, to come regularly on a quarterly basis, make sure the plan is updated alongside our development and that it's still relevant to the works that are taking place on site. So I know that's a bit of a mix of approach in terms of talking about climate change risks, but that we are seeing wet winters and hot dry summers, and those are the big 2 risks over the next 5 years that as a business we see we need to manage if we want to stay legally compliant, and that we need to make sure we're controlling if we want to control costs on site, and make sure we hit our program as well in terms of construction. So what I would really just suggest is have a look at the UK's climate projections, think about your own business, your own locations where they are, think about understanding what is likely to happen over the short term and how you can mitigate it, and then have a plan, and make sure that that plan is shared with the wider team on site, that it helps you to manage those costs across the life of the job, and that you do include it. So one of James's questions around when do you think about adaptation, when you're briefing, in your briefing before you invite to tender, you make sure that you are sharing that plan with the ground workers, with the contractors that are coming to your site, so they all understand what they need to do, can cost for it appropriately, and then can work in accordance with it. And my final slide was just to share a few references as well that we've used and we found really helpful. So there's loads of resources from the Supply Chain School, but there's also the Reading University and the UK Climate Resilience Programme provide loads of great modelling from UK CP 18, and the IAQM dust guidance is down there at the bottom. So, and just a few pictures and examples, and that's it from me, James, I think.
Super. Thank you very much, Ben. That was really, really interesting to see how one particular organisation is tackling the climate change issues that are pertinent to them. And as I was trying to get across earlier in my part, it's going to be different for different organisations in different geographies with different services and products that are going on with that. Okay, so we've got a Q&A section now. I can see there's a couple of questions here. Coming through on the Q&A. If you've got any more questions, now's your opportunity to post them. So please do get typing in the Q&A box. I'm going to pick up the first one, if I may, with you, Ben. And that's, how do you think that drought scenarios are going to affect the net gain, biodiversity net gain targets that the house building industry needs to meet? How do we manage those? We're trying to put more biodiversity in. We're trying to encourage the growth of wildlife, because there is a biodiversity crisis as well. And it's good at adaptation, but if we've got a huge amount of drought or flood, it's pulling in opposite directions.
Yeah, to a certain degree. I'll probably ask Andrew to chip in on this because he's our biodiversity expert. But for me, I suppose our approach to biodiversity net gain is that we will probably do a lot of the compensation off-site. So we will do it with a third party that are experts in managing that land. And the reason for doing that is that nature and communities don't always go together very well. So if you've got a piece of public open space on a housing development, you are never going to create an extremely diverse piece of wildflower land, because you can have kids sitting on it, playing football on it, riding their bikes over it. You can have cats in it, dogs in it. You know, it's never going to become a nature reserve. So we will do our best, and we will create spaces that support the community, support their well-being, and create a bit of nature. But predominantly, we're going to do that away from the development. And we're just started work with the Wildlife Trust, so on a NERC-funded project to look at how we actually do that. So we're a signatory to one of the funded projects there to look at how we develop those off-site compensation schemes, the legal tendering approach, and how we make sure that those habitats that we're generating can be managed in the long term. But I don't know whether Andrew's got anything more to say on climate adaptation.
Yeah, no, just chipping out, I'd say yes, we are going to be very much reliant on our appointed ecologists to advise us and guide us for a certain development. If we are trying to sort of increase a bit of biodiversity on site in certain areas, what species are good locally, drought tolerant, it might actually limit the number of species we can go for. We might even see some new species that we've not really ever used before. But I think the other interesting factor around the whole drought and flooding is I'm pretty sure actually it will become very challenging in areas for actually new habitats to establish. And I think there will be a risk to the actual delivery of what we say we're going to deliver on site, which is something in time that will be audited by the local authority to say, well, have you said you were going to achieve this on this site? Have you done it? And I think there will be a risk to establishing new plants, especially in drought conditions. You can imagine laying new turf. You wouldn't want to do it in this type of weather, and the same for trying to establish a new habitat. It would be quite a risk to manage. But again, we will be very much reliant on our ecologists, and it might be a challenge to our program, where when and where we can do it.
Yeah. No, excellent. Thanks both. I mean, it says essentially to me that the BNG strategy has to have adaptation built within it itself as well. The two go hand in hand. Yeah. Great. Thank you. Just for those who are listening, NERC is the Natural Environmental Research Council, one of the funding bodies. Sorry, I'm guilty of many an acronym myself, but yeah, so it's a funding body, and you can put applications in for grant funding, and there's various other research council bodies funded by the UK. Cool. We've got another question here about how are your dust and silt controls received or adopted and managed by your subcontractors and your supply chain. So this is not the wider stakeholder community of the schools and the businesses around you, but the guys that work in your supply chain. How is that received? And the age-old question of cost implications of that.
There are some cost implications, absolutely. I mean, the way let me start from the beginning, I suppose. Before we started to have this more strategic approach and write the plans early before we went out to tender, there was a lot of kickback because we hadn't put it into the tender pack and our subcontractors hadn't quoted or costed for it. So at that point, yes, we did have to have those conversations and say, okay, well, we'll pay for them over and above the package because we hadn't told them about it. Now we are including them and they are bidding on the basis of what we see as the controls we need for that development and the long term over the whole life of the job. So it's becoming a much more proactive conversation. We have seen very large unexpected costs where we've had to be very reactive in the past. So, we don't really want to be reactive and on the hop, putting additional measures in to cope with silt management. And that's very, very costly. So when we do it up front and we can explain why we're doing it with the contractors, it works much better. The challenge is often making sure that our staff and our subcontractors on site understand all that as well. So the guys at the coal face who are implementing those measures are competent and understand it as well. So we do a lot of work around that as well to make sure that it's not just that there's a budget there, it's that they understand it and can work on it as well.
Cool. And that's really useful for me, because there's one of the questions I had for Ben and Andrew, which is about how you engage your stakeholders. And clearly one set of stakeholders is supply chain and ground workers and so on. Do you want to just embellish on that a little bit, kind of the routes to that engagement, so you get not only the understanding but the actual engagement to implement as well?
Yeah. So I mean, we do a fair amount of engagement through the sort of pre-let meetings and the pre-start meetings with our subcontractors. So that's a relatively high level to get them on board and understanding the costs. Once we get to a lower level, we have an induction tool called Go Contractor, which is sort of an internal site induction tool. We're using that to start bringing through toolbox talks and online training so that we can demonstrate that those subcontractors have been trained. We can track their training and we can see that there's some competency testing there so they understand it as well. We then work with our site managers so they get a full day of environmental training within the first 3 months of starting with the business, which we repeat on a 3-yearly basis. And that makes sure they understand the onus on them to implement the plan, understand the plan, and control it and inspect. And we sort of support along that journey, so we don't just throw them in at the deep end. We then go to site and work with them so they understand the process and measures. Don't know if you think of anything else, Andrew.
No, I was going to say all I've seen again recently. This is a bit of with the warmer, wetter winters, and we are seeing more joint team visits, dare I say, to actually go and understand, look at the risks, and say, is it doing what we thought it was going to do? And quite often we're actually finding, well, actually no, we need some extra. Which again there is another on cost, but actually sometimes with the extremes of weather, we are saying you could have the best, don't get me wrong, you could have the best surface water management plan in the world on paper, but actually until it's there on site, you don't truly know whether it's actually going to be sufficient. So that's another thing that we are seeing, is that, getting every relevant stakeholder involved for that site, our team, technical team, construct, get everyone together and come up with a solution, and working together. That's the best way to do it.
And that's really good from my point of view, because we do a lot of work around the procurement and sourcing of services. What often we see is that it falls between the cracks when it goes from a procurement through to a contract management on the site. So it sounds like it's maintaining that momentum through that site onboarding, training, and following up. Coming back X months later to build on that. No, that's great. Thank you. I've got another question from the audience here about any examples you might have of innovative products or suppliers that have got solutions that help you with that dust and silt adaptation piece.
I mean, we work on silt. We work very closely with Siltbuster. So they provide a lot of settlement tanks for us and a lot of consulting advice. They also deliver the training for our internal teams. So they do a 1-day training course for our technical design teams, construction teams within each of our regional businesses. So that's a mandatory piece of training that we ask them to do so they understand the processes. So we work with them very closely. Less so on dust. I mean, the only supplier that we've really done a lot with specifically on dust is a company called Dust Scan, who produce it's like a fly paper disc that you put up around the edge of the site, and that as the dust blows over, it's captured on that sticky paper. Take it down every week, send it off, and they do lab analysis on it so you can prove. I mean, where we've had issues of complaints and we think that they're not justified, we will then go in and do monitoring and understand, how much dust is actually blowing off the site in a certain direction. But those are the two key ones. It's less specific on dust. We tend to just work with our groundworkers and contractors to manage it. Anything else, Andrew, for you? No.
No, nothing, Richard. Unfortunately, there's not. As I said, the Siltbuster tanks have been around a while now, but I've not seen anything sort of revolutionary that's come out that can help us deal with clay. Other than that, we have one site where we've actually got Siltbuster tanks, but we're also having to add a chemical treatment coagulation because there was that much clay and it receives that much water. That's the only way to clean it up. So, but yeah, nothing else to add, I'm afraid.
Cool, thanks both. There is a question here about examples of risk assessment in the rail sector. I think what I'll probably do is make that as a suggestion that we get someone from Network Rail in and some of the TOCs to come and talk about tracks and the various other assets, and especially if you've got overhead catenaries as well going on. I think that would make a really good lunch and learn with a couple of guest speakers from that sector as well, rather than us trying to bluff our way through how it's done in the rail sector. I've got a question here for both of you, if I may, about where you should start your strategy for adaptation. What's, if you've got people on the call today who are thinking, great, I get it, I know we need to do something, and I've heard about dust and silt, but where do I start if I'm at zero now on this? No pun intended with net zero carbon, but how do I get going with this?
So I suppose for me, it's talking to the relevant functions in your business. So thinking about who your operational leads are. So you can very easily do some initial modelling with the stuff from the Met Office, the UKCP, Climate Projections 2018. Take that, understand what's likely to change locally around your key sites, and then go and talk to your teams, whether it's your supply chain team about where you source your materials and your labour from, or it's your technical teams and how you design your products, or the construction teams and the sort of stuff that actually goes on your site. And it's not an exact science. You can put sort of the monetary costs that we've put against those. It's not an exact science. We don't know exactly what's going to happen, but it gives a feel of key risk and a feel of scale around those risks as well. And you're only going to get that by talking to the relevant functions. So, to get to those costs, we had to talk to our construction, technical and commercial teams to understand what we're doing now, how much we're spending, what the likely change is going to be, talk about the additional, rainfall or wet months, and then understand where the cost is going to come from.
Cool, that sounds good.
Yeah.
Andrew, do you want to add anything on that one?
Only for me, the key bit was actually, because we are generally a construction company, was actually that chat with the site teams. They have to deal with it day to day, and they're a really good starting point today. They already see what is happening. They're noticing the change. Some of the site managers are saying, yeah, never used to see rain like this. So it's they're a good starting point. Actually, the guys on the ground doing the job.
Definitely. And I think what I take away from that is, even if you haven't got the perfect answer, it's better to start with something than nothing.
Yeah.
Like Ben was saying, the costs are the best they have at the moment. Those will be refined over time. So don't wait for the perfect model or the perfect scenario to turn up. Just get on with it. Great. And thank you both. My final question, because I think there aren't any more from the audience. My final question this morning or this afternoon even is, how would you measure success? And I do air quotes deliberately, whatever success means. How would you demonstrate success in an adaptation scenario? How would you prove it to your stakeholders and say, yep, it's working?
I suppose that's I don't know. Andrew, do you want to answer that one first?
I will try. Well, say if we look at potentially, you could say two key risks, dust and surface water. Now, you could say that we would be successful if we see a number of dust complaints reducing, or maybe even staying constant. With maybe actually we've got a baseline, we can keep it at what it is, or the fact that potentially we've not got to a point where the EHO and the local authority are saying we're actually going to put an abatement notice on your site. That to me, that would be, if we're managing it correctly, we should be staying on good terms with the EHO and the local community. I would say likewise with surface water. Again, if we are successfully managing that risk and adapting and making sure our plans are robust enough, then touch wood, fingers crossed, we won't be, I'd say, having that regulatory interaction with the EAC Pro Natural Resources Wales and ended up with a huge prosecution. So in immediate terms, for me, it's just staying compliant and staying out of the courts in some respects as a very black and white sort of answer in a way. Just so that will.
Yep. And I think maybe that's where I was getting a little bit, because if you think about adaptation at the top level, it's so enormous. How on earth do you say we have adapted our whole business to climate change? I think Andrew's probably right, thinking about each of the topics in turn and being able to think about what the success factors look like on a topical basis. So whether it's adapting the homes that we build to a changing climate, or putting more nature on site, or the immediate challenges that we've got around construction and surface water and dust, I think you're right, it's going to be different for each of those topics.
Yeah, no, I like that. If you can demonstrate that you're having no more complaints than you would have otherwise, and yet you're dealing with higher risk and higher frequency of dust events, then yes, you're doing the right thing. Great, thank you very much. We're coming close to the end of the hour. Just one final remark from me. I was listening to a news item that I've just reminded of from Ben's presentation about the changing seasonality of nature. That there's been a study that's been going on for over 100 years in some woods near Oxford called Whiteham Woods, and they've measured with the longest data set that common house garden birds like blue tits and blackbirds and stuff are nesting 3 weeks earlier than they were 100 years ago. The whole of spring has shifted forward by 3 weeks, and at the moment it's all been adapted to. So the birds can nest 3 weeks earlier. The grubs that they eat come out 3 weeks earlier, and the trees and the plants that the grubs eat come out 3 weeks earlier. But there's going to be a limit to that, how much earlier it can get. So at the moment, that ecosystem has adapted by 3 weeks, which is quite significant in a year. But how long it can go on for remains to be seen. On that bit of a note, I'm going to say thank you very much to my guest speaker Ben and his colleague Andrew. Hope you found this useful. We do have a feedback form which is in the chat box. So if you go to the chat box, not the Q&A one, the chat box, you'll see there's a post there from my colleague Toby. He's put in the feedback form. Please go and complete that. It'll take you like 3 minutes or something like that. Other than that, we will share the slides and the recording as well. So thank you for your time and attention. Hopefully it was useful for you, and hope you enjoy the rest of your day. Thanks for now. Bye-bye, everyone.
Thanks. Bye.